Good evening. My name is Bashir Fancy. I'm one of the co-founders at BIZTEK Professional Association of Canada, BTPAC, as you see on screen. We're representing both business and technology. We're a not-for-profit organization that's all about training, certification, continuous education, sharing, mentoring, body of knowledge, code of ethics, and you can join BTPAC at no fees. We have kept certainly for the first year, no charge. And we want to keep it that way as long as we can figure out the funding part. Right now, just so that everybody's aware, we're funding this ourselves, me and 3 of my other colleagues, for the very simple reason we believe in this very strongly. We have passion for doing this, and we've been fortunate in our life. So that's what BTPAC is all about. And you see us, if you go to btpac.org, you will see exactly what I'm talking about, because we got all sorts of blogs, articles. We're doing research. We are certainly providing training and certification. We are partners with ICCP. So here today, we're actually going to bring you a very interesting subject about blockchain. And I'm very fortunate, BTPAC and me and my colleagues are very fortunate. We have actually Shakil Muhammad from Seoul, Korea. We have 13-hour time difference, so we're doing it right now. He's going to be speaking about blockchain. What I've requested him to do is to make sure that we actually today deal with both business and technology, keep it a little high level. And as we do future things, he's going to drill down further. Shakil is actually CEO of RNS Solutions, and he's also part of the Metaverse in Canada, so it's part of that same organization. He's been 15 years doing this technology, and he's worked with some of the giants in Korea. We all know names. I don't even have to go there. And he's written a lot of research papers that are available, and we're going to be posting some of the things on our website very shortly. He, with a couple other people, he's a PhD in this area and done some fantastic stuff, as you hear. So anyway, today he's going to talk about both business, the high level, and then in the future sessions, we're going to drill down. He's also going to be involved in doing research. As I said, a lot of his papers have been published for research, and he's going to lead the research for us with obviously X number of people on blockchain, how it can be applied, what are the benefits, how it can be used, the whole works. So I don't want to take any more time other than welcome everybody here and hope that you do get benefits out of this, and look forward to working with you people. So don't forget, it's btpac.org. We're going to post this video there too, as we'll post a few other places. But if we got a lot more content there, please do go there. More importantly, join us, because it's not going to cost you anything at the moment. And we're going to try very hard to keep it that way. So thank you for allowing me to do that. And let's take it away, Shakil. All yours.
Hello, everyone. Today we are going to talk about blockchain and demystifying this technology and some research challenges and some use cases. So my name is Shakil Muhammad. I have done some degrees from KAIST, Korea Advanced Institute of Science and Technology, and then I have 14 years experience for software development related to cybersecurity and a few years in blockchain. So I have published some research papers in different journals. I'm editor at IEEE, and I have a couple of startups and one company called RNS Solutions. RNS Solutions develop blockchain, cybersecurity, AI related software. So, so you can go on our website, www.rnssolutions.com, rnssoul.com, or just Google RNS Solutions. You will find more about RNS Solution there. So why blockchain? Why we need blockchain? In past, we are using ledger to keep record of our transactions, but it was so difficult to prevent destruction, or keeping permanent ledger. We have so many incidents in history where people lost their ledger and they do not have record of it, and they cannot recover back. So in digital age, we come up with the digital ledger, but some of the problems still remain there. For example, in digital ledger, in digital age, we can still temper digital ledger. So what is the way forward? So I have my money, but that is controlled by somebody else in digital age. For example, in this case, banks are controlling our ledger, and they can forge at any point to take advantage of it. And the banks are doing all the time. So I'm going to going to explain the history of blockchain. So, and the blockchain is the way forward that help us to have immutable ledger. So actually, it's not well known who developed this technology. So this technology is not one technology, it's a combination of many technologies. It's kind of a fusion of IT, cryptography, and communication. Instead of IT, I will say ICT and cryptography techniques. And there were existing techniques. Somebody took those techniques and put it at one place. And these are the people, those are most probably one of them who created this technology. So actually it started with the rollout of Bitcoin after 2008 financial crunch. And I highlighted Vidai and Hall Finney because they somehow fill up the criteria of being the founder of this technology. Their background, their technical how now give us idea they might be the founders. Vidai still lives, but Hall Finney has passed away in 2013. So when Bitcoin rollout, it pick up some pace after some time. So I'm going to explain how the technologies roll out and how they pick up pace in real world. So usually you have some app, and that app inspire you to have infrastructure. So first we have apps, and then infrastructure inspire us to take next level, next generation of apps. For example, if we see the World Wide Web apps and the infrastructure development, initially when we have internet, this infrastructure gave us idea to develop, do messaging, and then we develop new tech stack or the infrastructure, Ethernet, TCP, IP, and then we came up the new kind of technologies like AOL. Then we developed another infrastructure to support next level of technologies like IMDb, Dr. Fun, Pizza Hut, eBay. And this is how the technology is moving. If we see after 2007, we have iPhone, Android, smartphone, and then we develop a new infrastructure, app stores to build next kind of apps. And when we have that, when I say infrastructure, it is not only the hardware infrastructure, it is not the only techniques, languages. Infrastructure mean all the ecosystem that help us to develop new kind of applications or use cases. So this is how we are moving in ICT industry, in World Wide Web and mobile. So what is the status of blockchain and how we are moving? So the blockchain came up through the Bitcoin in 2008, and then we have Ethereum that give us some interoperability, some scalability. When I say interoperability, mean when we have a Bitcoin, we want to make a new blockchain or new infrastructure or new app, we have to just fork that Bitcoin and change the code. So we cannot interoperate between Bitcoin and the next blockchain. So, and we do not have the only one infrastructure and we just develop app on top of it. So Ethereum came up with the concept, why not we put virtual machine, as we have virtual machines in computing world, and the lower layer of blockchain, for example, networks and networking and the consensus algorithm remain same. And the only apps or the use cases we need to change. So that was a revolution that started in 2015, and then there were extra layers that came up, like there was a standard ERC20, then there was web extensions like MetaMask, and we came up with the new apps like tokens, ICOs, and CryptoKitties and Uber. So now we are at the edge of the new infrastructure. The people are developing a new infrastructure. Many companies are developing. We are coming up, okay, how the blockchain can work as an internet, how we can have protocols like TCP/IP that blockchain can talk to each other. They are interoperable. Still, you manage your sovereignty, but and you have scalability, but they are interoperable. So this is the era of the generation 3 blockchain that we are moving forward from Bitcoin to Ethereum. Ethereum gives us the real use cases, and then we are moving to the blockchain generation 3 for the mass adoption, I believe. After this infrastructure, I believe there will be mass adoption. So how the blockchain transactions happen? For example, Alice want to send some coins or data or Bob. When we say coin, it's also a data. So when we send some data from one user to another, so we have a concept of wallet. If we just consider as a money, so we are moving these coins to another, it means I am handing over the ownership of my data to another user. So I have my wallet, I sign up my transaction, I send it to the Bob, and the network, this decentralized network, helped me to move my data to the another user, whether it's a cryptocurrency or whether it is data. So how the blockchain actually, we are tackling this transaction, this presentation not only for the executives, but we believe there might be some technical people as well. So we are balancing this for the presentation with the business executive, as well as for some interesting stuff for the technical people. So how the blockchain transaction happened. This is the machine story. So the previous was a user story. So how it's look like toward the users, how it will look like to the machine now. So we have a wallet, it signed the transaction using private key, then it's sent to the P2P network. It does the gossip protocol, it talk to each other and do some consensus. It's sent to some validators. Those are maybe miner, those may be proof of stake validator. Then it sends us the verification, okay, this transaction is right. And then it goes back to the confirmation of our wallet. So this is the machine story of blockchain transaction, how one blockchain transaction happened. So what is in this block when we are saying blockchain? So actually these are a chunk of data that is connected to each other for the immutability purpose, for hashing that data, and so it cannot be unhashed. Hashing is one-way process actually. You cannot come back. So when you do hash on hash, it's very difficult to decrypt. It took longer time. So that's why we say it's immutable. Even in quantum age, that is a magical word. I usually say the quantum world will be the magical world. There are algorithm, hashing algorithm like geometric algorithm, they will be preventing us to unhash. So in block, there is a block header and then there is a block data. So block data, we can say our transactions, actual ledger transaction, and block header is kind of a metadata that contain extra information that help us to move on our ledger. That is not useful for the user, but it is useful for the machines or for programmability. So I will skip this transaction part. I don't want to go more technical into details. So we might have another session where we might explain like how these transactions work. So this is a proof of work. This is a consensus algorithm. If we slice blockchain in three sections, one is networking part, then the second is consensus layer, and the third is the application layer. So in networking part, we have a P2P networks. They're doing protocol chat. There is not much innovation in this networking part yet, except one or two public blockchain. They are putting effort to change the network layer as well. One of them is a Cardano. So so how this proof of work algorithm works? We have a P2P network. In P2P network, we have a different nodes. They send puzzle, and this puzzle has been solved by some miners. These are validators. They are part of this network. And when they solve this problem, they send solution back to the network, and everybody get that solution. And then whether if the solution is right, it's sent back to the send rewards to the miners or the validator. So this is how it works. We can go more into detail when we have a technical session. So I will move on to the next. We call Bitcoin as a UTXO model. It's an unspent transaction. Why I am presenting this UTXO transactions? This was the magic of Bitcoin, one of the magic. There's many innovation, but this was one of the biggest problem that Bitcoin solved, unspent transaction. There was no mechanism before. We have the proof of work consensus algorithm from many years, but we do not have, and we have networking layer, how P2P protocol can work. But this application layer of Bitcoin that was unspent transaction, I have a one coin or $1, and when I spend half of it, the whole network and everybody should know, like, okay, I have spent half of the dollar and I keep half of the dollar. So the Bitcoin works on this, but usually in our real world, we are using account-based model. We keep our accounts in our banking. So Ethereum, another invention for. So for Ethereum, we there was and there were many innovations in Ethereum blockchain, but one of the biggest one was moving to have a virtual machine where we can have our application. We keep the whole stack consensus and the network same like Bitcoin. Ethereum also work on proof of work. They are moving to proof of stake maybe next month. And another was they come up with the account-based model. So usually when we say in term of transactions or in term of accounts, we call whether it's a UTXO blockchain or whether it's an account-based blockchain. So generally we divide blockchain in three different type of blockchain: public blockchain, private blockchain, and the consortium blockchain. So I will explain how the computer systems look like throughout the history. So we have centralized a computer system, then we have a distributed computing system, then we have decentralized computing system. So in centralized computing system, when we go back in the mainframe era, we have one computer machine that is doing all the computation, and the others are dumb terminal. Those are connected to the centralized computing. machine. Then we come up with the internet that connects those different computation part and come up the age of PC. And then we need these kind of distributed environment, how we can collaborate, how these machines can collaborate to do computation. Then we are moving to the decentralized computing. So actually decentralized is subset of distributed computing in computer science. So if we see this client server versus P2P networks, in P2P networks, there are peers, there's no central authority. In client server, we have central authority of a server, and that is sending, that is controlling the whole application or the whole network. So when I say in blockchain, three type of blockchain. We have private blockchain. The technology behind them is IBM Ethereum Alliance and R3. These are most popular private blockchain infrastructure that you can leverage their code and can develop your own private blockchain. So in your private blockchain, you can have your own nodes and you can have your own peers. You can have your own certificate authorities, and then you have a central ledger, and some people have authority to change that ledger, and some people have authority to verify that ledger. So it's good to have B2B transactions and to use in some organizations. As a whole, we want the bigger part of the blockchain for the mass adoption. So then there is consortium blockchain similar to Facebook. It's kind of a private, but it's a consortium. We trust top companies or top organizations, so they are coming up with their blockchain, and we believe, okay, they will not make they will not change ledger without any reason. So these are kind of consortium blockchain. But the biggest part is public blockchain, Bitcoin, Ethereum, and I mentioned Anthlia. Anthlia is a concept that our company is doing for many years. It's like adding to the community, giving some research, learning from them, doing proof of concepts. So it's a non-profit project for us for research and development. And there's other public blockchain. Cardano is a third generation blockchain. Cosmos, I love that. That is also third generation blockchain. So these are three types of actually blockchain. When you say blockchain, you have to see what is the use case and how you can use that, what kind of blockchain you need. Maybe you need private blockchain. You do not need to spin public chain. And maybe you need public chain. And then in public blockchain, there are many different kind of blockchain. You should know there should be some consultant who knows what is the use case and which blockchain, existing blockchain fulfill your need. And if there is no existing blockchain, then you can take at least the component of that blockchain and build up your new one according to your use case. So I believe there is no single blockchain in the world that fulfill all the requirement of work. So it's different components. I usually give example to people. In web technologies, we have ton of technologies. We have ton of programming languages, and every different tech stack or the different programming language cater some different programming, different challenge. For example, Golang is very good for when you have concurrent processing, and the node is very good when you have kind of a centralized service. There's no concurrent processing or parallel processing. So yeah. So in blockchain, we have also different kind of blockchain. These are combination of different algorithm techniques. You should know when you have some use case, or your consultant should know which part and which blockchain you are going to use. So the blockchain, as earlier said, the blockchain we can divide in network layer, consensus layer, and then we have an application layer. So what is in network layer? It's a P2P networking logic. This has nothing new. We are doing from P2P networks from 70s and 80s. There's a lot of experimentation, not much scientific progress these days on P2P network. It has like peers discovery and then broadcasting information. Then we have a consensus algorithm. When we are talking decentralized world, we want every peer or the node to have the same information. These are a few popular consensus algorithm: proof of work, proof of stake, delegated proof of stake, and my favorite is practical Byzantine fault tolerance. So this PBFT or the BFT algorithm is also not new. The first research paper, the first laboratory implementation was in 1988. And the first practical implementation, the production level implementation, I will say, came up in 2017. And now many organizations are trying to use PBFT. Chinese yuan, I heard about it. They are going to use Taiwan identity organization, like keeping your national ID. They are going to use this one. And then we have application layer. This is our real use case. If we have monolithic architecture, so it was very difficult for us to build different use cases from over decades of our ICT understanding and the software understanding. We come up on this stage where we want modular approach. We want to have a separate parts. If we are changing application, we don't need to change consensus or network layer. We supposed to have like minimum changes there. So application layer, we are until now the industry is coming up with many virtualization. For example, if you do not know network layer and consensus layer, and you know your application as a programmer, you can program your business domain on blockchain. So there are more virtualization is coming even on top of application layer to do interoperability between different kind of blockchain. So as I said, blockchain is divided in these three layers, three type of blockchain. Usually I'm using three, so it's easy to remember. Then we can divide blockchain generations into three generations yet. It's easy for us to understand. When we move to the generation 4 maybe, then we can put the generation 2 back into generation 1. So next time presenting generation 1 and generation 2 blockchain, there was some goodies about generation 1. It was sovereign. I mean sovereign mean, for example, if you want to change any hashing algorithm when you are forking Bitcoin and making your own new use case. Bitcoin is a use case for as a money. It is working as a payment system, but you want to use for naming service. You want to use it for storage application. So it was sovereign. You just take the fork of that blockchain and you change every piece of the blockchain you can change. And the state machine was efficient. When we say state machine, that is doing computation there. That is a state machine or maintain the state of the ledger. And it's a customizable, but these are the goodies about the Bitcoin code. When I'm saying Bitcoin, there's goodies. I'm not going to talk, okay, it's a slow, it cannot, it is not interoperable. Everybody knows these kind of challenges. I want to talk the beauties of these blockchain. Then we came up with the Ethereum generation 2 blockchain. The beauty of Ethereum is interoperability of dApps. dApps are application. You have application and those applications can communicate with each other. They can transact data because we have virtual machine, Ethereum virtual machine there. And the good thing is they come up with new tools and languages. So it's easier to develop. And then you have deployment, like easy deployment. So in generation one, it was difficult to do all these stuff. So then but still, when generation one have some beauty and generation two have some beauty, but still some part was left. We need generation three. So many blockchain is taking benefit of generation one good part and generation two good part, and they are adding some extra feature in generation three. For example, they are trying to make it scalable, because both previous generation was not scalable. When I talk about scalability in next slides, I will say more about scalability. It should be fault tolerance. It should be sustainable. When I say sustainable, sustainable mean it should have some governance module or treasury. It can run by itself. Then there should be some privacy. We don't want our data to be on blockchain that is visible to everybody, because blockchain gives us immutability and good security, but it doesn't provide us, it doesn't cater privacy, because it doesn't build for privacy. So there's many new innovation is going on for the privacy. So research challenges and use cases, I will skip this. When I say scalability, in scalability, we have scalability. Usually people say transaction per second, but when we say scalability, I divide in three parts. We need to tackle throughput. That is also different three. I will again go with the three: throughput, transaction per second, metadata. And then we have a storage problem, and then we have network delays, because these are distributed computers, and if the delays are higher, their processing speed or settlement of the block or consensus will be slower. And for storage, because every computer is keeping, or every node is keeping the copy of the whole ledger, how we can come up with the efficient of storage. So these are some of the challenges those third generation 3 blockchains are trying to cater. So when we say scalability challenge, if we see as a payment system, as a use case of blockchain as a payment system, so Visa transactions are 2,000 transactions per second currently. They tested like, they have a stress testing over 50,000, I believe. But in real use case, they are doing 2,000 transactions per second, and the whole world is, the whole network is working fine. PayPal is 136 TPS. It still didn't reach to their peak. And Bitcoin is 3.8, and this is very small. Another, when we say the throughput, we forgot the blockchain transaction is 10 minutes. I think there is a typo. Actually, block creation time is 10 minutes. So in Ethereum, we have 15 transactions per second, and the blockchain generation is between 10 to 20 seconds. So the blockchain generation means when we have a one block, we put all our transactions, this 15 in one. So we were talking about interoperability. Many companies are coming up with the TCP/IP kind of a protocol, so we can have internet kind of protocol where we can come up with the new era of the blockchain usage in real world, with coexisting with the digital system. Way to achieve interoperability, there's different kind of oracles, and the solution, those are coming up. So we will go to some use cases right now in blockchain and some trends. One of the biggest use cases, decentralized identity management. And many big companies, IBM, Microsoft, they are coming up with this decentralized identity management. And still, there is no single solution that fit the entire market space. We have around 200 countries, and there will be different kind of decentralized identity management. There was one Rohingya community, they approached us to build their decentralized identity management because they lost their country and they do not have their identity anymore. They do not have any passport. So at least they can have a central system where they can present to different governments or organization, okay, my data is here. And so these kind of trends are also very popular. And then in cryptocurrencies, if we say decentralized currencies, Bitcoin, Ethereum, and other around 10,000, I believe, different kind of tokens are there. There is a new trend of stable coin. When we say stable coin, the value remains same. It's not going up and down, or it is pegged to some existing fiat currency like US dollar or euro. Those are stable coin. Stable coins have also different categories. Some are some have collateral, like DAI have a collateral of maker, and then there is very popular coin Terra in Korea. It is created by one of the giant e-commerce company. They have their own Luna and Terra coin, and then they have a collateral-based stable coin. So the collateral actually fluctuate, goes up and down, and the stable coin remains same. For example, in DAI and Maker, the Maker values goes up and down, and the DAI remains stable. It keep one coin stable. The central banks, when we say central bank digital currencies, hopefully they're gonna be this kind of stable coins, or maybe multiple collateral behind the one digital currency. This kind of central bank digital currencies research is happening these days. And then we have some monitoring tools, exploring some data related to blockchain. And then there's like lending platform. These are very popular these days, decentralized lending platform, because the centralized lending platform, the people don't trust them, and they're taking higher fees in fiat world. So there are different kind of lending platform. People are coming up with decentralized lending platforms. So the borrower are the people who are depositing there, they took advantage of it. Then there are insurances. This is the this is also very good chance for the insurances to move their assets on blockchain. So their managers or the fund managers cannot misuse. So in past, there's a lot of misuse in insurances. So decentralized finance, as I said, is a very hot trend in blockchain these days. So blockchain use case, these were like cryptocurrency or a payment system, blockchain as a payment system. So still I believe the first use case or many first use case will be these payment system. But after the payment system, then we have ton of sectors where we can take advantage of this immutable ledger or mutable database, and we can use in energy sustainability, in government and public sector, in healthcare. We were developing one use case, for example, in North America, I believe, especially in US, if you want to take your personal health record from one hospital to another hospital, it take around 1 month because of many regulation in health industry. So if we have some kind of mechanism that help us to take our data in our control, so some part of data we can share with some other institutes. So this is one kind of a use case in a healthcare. Another is this data is very valuable, but our personal information is very dangerous if we use share our personal information with our health information. but the health information for research is very important. For example, all over the world, COVID-19 pandemic these days, if we have all data centrally, the whole world is sharing, putting data at one place, just taking out the PII information, personal identity information on one side. So the blockchain can help us to the custody problem of this kind of data, and the owner of data. For example, I am an owner of data. I can authorize where I am selling, where I am using, and if that user is going to sell somewhere, I will get notification, okay, he's going to use my data for other purpose. So the blockchain is going to play a vital role in healthcare data and many other area. For example, in 2017, I was helping one startup from UK that want to resolve counterfeited, to detect counterfeited drugs. And still, in many countries, especially in third world, this counterfeited drug is one of the biggest challenges. It's taking billion of dollars. It's taking hundreds of thousands of lives. So in international trade and commodity, I was meeting one of the very pioneer in B2B e-commerce platform in Korea. They are earlier than Amazon and then Alibaba, EC Plaza. So they want to do innovation. They want to use also blockchain. They want to change this existing situation of their business or their ecosystem. And I saw there's a ton of problem in international trade and commodity. There's more regulation, and blockchain, especially the custody or the record, okay, whether this record is right or wrong, and there's a ton of forgery there. So blockchain can play a role there. So we can use in law, media, and entertainment. We are doing, I invested in um, uh, one startup here in Korea that is called Story Chain. How you own your own story. You write on some platform like a Twitter, and you have an editor there, nice editor, where you can write your story and your readers can come up there. You can same time monetize there. You can put ads on there. So it is going to play a huge role in media and entertainment, in story, in content, in media. Mr. Trump always say fake media. When we have decentralized media solutions, that will help us a lot. One platform, one startup from Canada, it is tokenization of assets. So the tokenization of asset is, his platform actually provide tokenization to every platform, but specifically his platform is firstly catering real estate. The funding in real estate all over the world is a challenge, especially cross-border investment. For example, I can see in Canada, the real estate is a lucrative market. I am in Korea, I want to invest there. There's a ton of third party I have to pay to invest there. So his solution is giving crowds to reach out to investor and invest in good real estate or in good platform. And then on top of it, that is tokenized, not only the accredited investor, but the small investor like who have small money can also participate in a bigger projects. And in sports and esports, these days, I will say MMA or not MMA, they called it some other name. They just collaborated with some blockchain community from Malta recently, and they organized their event. So in supply chain, for example, you are moving container, our all trade is going through sea, and most of our supply chain through is sea. So there is a solution that we help in 2018. They called BIZTEK. So how this they can trace your own items or um, your goods in real time using blockchain. So in crowdfunding, as I earlier, initially there was a buzzword ICO, initial coin offering. There was no regulation. Some countries have a gray area and people took advantage and they raised millions of funds. So I'm against of that, like kind of ICO, but the actual concept, if we see the whole crowd can participate, you have an awesome idea, you did not have that kind of background where you can have some uh, investment, so you can share to the public and you can raise funds through the public. Um, so then there is different kind of these crowdfundings are there. So I earlier mentioned tokenization of asset in real estate. MetaVest, the actual company name is MetaVest. They are also kind of a crowdfunding platform as well, along with tokenizing assets. So I believe there's more use cases. There's energy trading going through the blockchain. In Korea, we have one energy agency they are using. They are one of the biggest user of IoT devices in Korea. I did not know until I got to work with them. So I thought like their telecom industry is using, or the Samsung is one of the bigger usage of IoT. So they want to use they took that data from IoT, so many GBs of multiple GBs of data, and they did data analytics and making shape of that data. And then they want to trade that data with the other users in Korea, but they need some kind of mechanism where that can the blockchain can play a role. So there's 100 of use cases. I participated International Telecommunications Union one workshop back in 2019. There was working group. They also spent around 2 to 3 years um, from all over the world, from China Academy of Sciences, from Brazil Development Bank, so and ITU, and they come up with several use cases as well. So I think I will end up here, and we will have some more detailed session some other time. So if you have any questions, you can post me, you can send us.